So let's have a brief synopsis on pair of straight lines. Now basically pair of straight lines are of two types. A pair of straight lines intersecting at the origin. Let us say y is equal to m1x and y is equal to m2x are the two straight lines. So in the first part, let us discuss critical points about pair of lines through the origin. Then you can write a combined equation of the pair and get a form ax squared plus 2hxy plus by square is equal to 0, which consists of these two lines. And then you will have sum of slopes is equal to minus 2h by b and product of slopes is equal to a by b. So this is let us say the basic aspect. The angle between these two straight lines is given by theta is equal to tan inverse 2 into root h square minus ab divided by a plus b. Of course, when the lines are perpendicular, a plus b will be 0. Then to this pair, you can have a pair of bisectors, which again pass to the origin, and the combined equation of pair of bisectors is h into x square minus y squared is equal to a minus b into xy. Then suppose we have a pair of straight lines passing through the origin and we want a pair which is perpendicular to this pair. Suppose you take the first line, let us say this is L1, this is L2, and you draw a line perpendicular to it. I'll call this L1 dash, and to this you draw another line which is perpendicular, L2 dash. Then this new pair which is perpendicular to the old pair. So equation of the pair perpendicular to ax squared plus 2hxy plus by square is equal to 0 is, just reverse the coefficients, bx squared plus ay squared. Middle term remains the same but with a reversed sign. So these are the basic principles of pair of straight lines passing through the origin. Let us then go to the pair of straight lines not passing through the origin. So let's take a situation where we have a pair consisting of L1 and L2 but not passing through the origin. So they are not intersecting at the origin. So such a pair of lines is given by the general form ax squared plus 2hxy plus by squared plus 2gx plus 2fy plus c is equal to 0. In fact, such a generalized equation can represent many things depending upon the relation between coefficients. But this will represent a pair of lines if a certain condition is satisfied. That condition is abc plus 2fgh minus af squared minus bg squared minus ch squared is equal to 0, which can also be put in the determinant form. Determinant with ABC on the diagonal, symmetrically H, G and F. This will produce the same thing. Then the point of intersection the point of intersection of these two lines is given by a simple technique. You take dou s by dou x is equal to 0, dou s by dou y is equal to 0. That is, differentiate this partially with respect to x, then partially with respect to y, and then solve that. You will get the point of intersection. Then if s is equal to 0 represents a pair of parallel lines, the condition h square is equal to ab will be satisfied, and the distance between the parallel sides will be 2 root g square minus ac by a into a plus b. This will be the distance between the parallel sides. And then we can have one more point. Suppose we have origin there and you draw perpendiculars. Let us call the perpendiculars as P1 and P2. Then the product of perpendiculars is given by mod c by root of a minus b whole squared plus 4h squared. So like this we can have some basic information about which many problems can be decided.